So today I'm going to talk about OpenStack versus Ganeti. How many of you have never heard of Ganeti before today? Most of you. Okay, good. I'm assuming most of you have heard of OpenStack.
Unfortunately.
Unfortunately, yes. I feel the same way. So I'm going to kind of talk about this. Ganeti is one of those, it's kind of like the opposite rule of the Docker rule, is nobody ever talks about Ganeti. And they should. So before that, let me kind of give you a little background about me so you can understand where I'm coming from. I'm the director at the Open Source Lab at Oregon State University. That's what the OSU means in there, not the other ones. We provide a lot of infrastructure hosting for open source projects around the world. We host folks like the Linux Foundation, Apache Software Foundation, a whole bunch of other folks. I'm an ops guy by trade. I've been using Ganeti since 2009, which is when the version 2.0 came out, which was a major overhaul. And I've also been OpenStack ops person as well since about 2013. We've been running a little bit of that. So this just kind of gives you a little background of why I know what I know. So, and I've also been active in the Ganeti community for quite a while. So what I'm going to kind of do today is kind of talk about an overview of how cloud computing works, or not works, but the needs that people have and kind of how it fits in between different things. Quickly go over an OpenStack overview, but most of you probably already know that. And then I'm going to kind of walk you through what Ganeti is, what it is, isn't, kind of walk through some slides to show you kind of what it looks like on the command line, and then I'm going to talk about kind of comparing both and kind of seeing things. This talk is about, I'm not going to bash one or the other more or less. This is one of those finding the right tool for the right job, and they can both coexist potentially, and it really depends on what your needs are in your infrastructure. So feel free to ask questions at any time, and I'll go through that. So first off, cloud computing resources. Everybody has different needs and what that actually really means. I started using Ganeti before cloud was the term we used all the time. It came before OpenStack, before libvirt even. Some of your needs are small and simple, some of them are large, and you need a lot of different things. Maybe you don't mind having a complex system that allows you to have a lot of flexibility and elasticity, or maybe you just need something simple that just does simple computing needs and that's it. Another thing to consider is cost. VMware is a pretty big player out there. It does a lot of things that Ganeti basically does. It does it really well, but there's other things that it does well that Ganeti doesn't do well. And then you have to deal with licenses with that. But with Ganeti, it's open source, so you don't. So typically, I'm assuming all of you out there have used at least one of these tools. Either use VMware, Overt, Apache Cloud Stack, OpenStack, some public cloud, and insert your favorite solution that is also out there. There's many, many others that have been out there over the years. And they all have their pros and cons. But as I said before, Ganeti is the one that nobody ever talks about, but they should. So as you're sitting here, you need to start thinking about what is my use case for the virtual computing needs of my organization. Do I just have a small set of web infrastructure that just maybe hosts some PHP sites, some simple things, they're kind of more pet VMs, or do I need something that's highly dynamic, can scale things out, I can spin things up, tear things down, I need to have a whole bunch of private networks, interconnected, availability zones, things like that. Are you planning on having your VMs around for a long time? Your more traditional kind of IT pet VM, or are you wanting something short-lived? Or do you want a VM that actually is more highly available, or do you want to build that into the service that you've created? And you also have to consider the users of the system. Do they need to have an API to be able to spin up things and spin things down? Or is it basically just going to be you as the admin managing this? And you can just do that all yourself in self-service. So there's a lot of things to consider throughout all that. As we know, OpenStack is all the hype right now. Everybody's talking about it. Everybody wants to get on board with it. Even we are, so to speak. And I'll kind of talk about how that goes through, but it's really designed to scale and kind of be like an AWS replacement, almost. It's still maturing as a project. There's lots of various sub-projects inside of it. Some go stale, some go active, some are really stable. It's mix or match. There's a lot of features and things you can plug into OpenStack, but I bet you a vast majority of you don't need. But they've been adding a lot newer things that might be of interest. Load balancer as a service, or other things. There's lots of things in there. And I love showing this diagram, the OpenStack Architecture diagram. That is actually from their website. I love this.
Did it have color?
No. No. But essentially, OpenStack is a set of services that all provide APIs, and they all talk back to a message queue and have a database component. And they all have to talk back and do everything. And any one of those things break, you're driving yourself nuts.
So is this supposed to get people to want to use OpenStack or not to use it?
I'll leave that up to you. But yeah, it's really crazy. In my experience in the last 2 years trying to deploy OpenStack, this is the thing I hate the most about it. But the nice thing is once you figure that out and you get it working and it's mostly doing things. And I should say the latest versions have really gotten it more stable and a lot easier to deal with. The versions that I've been running, like I started out with Icehouse. It was getting better, but I'm still dealing with issues, and I'm trying to get Liberty to go now. Liberty is working so much better. But the nice thing about OpenStack, it has a standard cloud API. It's very similar to what people are used to in AWS. It makes really fast VM deployment teardown. Makes it really easy to do elastic computing needs. If you need to have object storage, block storage, virtual networking, that kind of stuff, it's great for that. There's really huge community. In fact, there's a summit next week in Austin that is actually pretty big. When I went to the Vancouver one, there's probably at least 5,000 people at that summit. It's crazy. It's probably larger than OSCON. It's quickly growing. There's new features that keeps getting added. They keep making it better. So there's a lot of movement in it. There's a lot of things going on in it. The thing about it that I really hate is it's a pain in the rear to deploy and maintain. They actually created a tool that uses OpenStack to deploy OpenStack.
When you use OpenStack, do you get a package distribution-like version of it from a Red Hat or something like that?
Yeah. So like we're primarily Red Hat shop. So Red Hat has a project called RDO. I don't think they even remember what RDO stands for, but that's the repository that keeps all the packages. So you basically, it's kind of like Apple, but for OpenStack. So you add the RDO repository, and it just works. So that's what we use, and I think Debian and Ubuntu is probably the most widely used platform for compute nodes and everything. So that usually works the best. And CentOS and Red Hat has kind of been the second-class citizens because it kind of started out after. Everybody that's developing OpenStack basically uses Ubuntu. So the other thing about OpenStack is there's so many moving parts. You remember that slide I showed you before? Lots of moving parts. And the project is still maturing. There's things like we've had problems where we actually used OpenStack for a sysadmin course that I taught, giving students access to that. They can't. The user interface has the ability for those users to change their password, but the version of that web UI and the version we were using doesn't have that API built into the UI, but it's built into the backend API. So if they use the command line interface, they can change their password, but they can't use the GUI. So you're dealing with things like that all the time, and things are constantly changing, and sometimes the projects don't talk to each other. And things drastically changed the past few years with the networking stack, especially. And the networking stack of OpenStack is just as complicated as OpenStack is whole. Just to put it that way. It took me 2 months just to finally figure out how to get my current setup going. OpenStack fits a really specific use case as well. If you're really getting into the elastic computing needs, it fits really well. But if you just need pet VMs that just run and do things, it's probably not the best thing to go with because of the complexity of it. And to really use it effectively, you need more than one machine. You need to have at least a controller node and a compute node. You could probably run it all in one, but you really never really want to do that. And upgrades, they're a pain. Supposedly they've gotten better in the latest versions, but basically everybody's upgrade plan is build a new OpenStack cluster with the newer version and tear down the old one.
Very familiar with that.
Does that also apply to just regular patches or just like
major version releases? So if you go from one version to another, they have a release cycle, I think, every 6 months, kind of similar to Ubuntu. There was ways you could do it in line, but I went to, I think, to 3 different presentations last year at the summit that talked about how to do it. And it was the most meticulous thing. You have to do things in a specific order. There's database migrations. They change things. And if you're moving from the older version of the networking to the newer, good luck with that. Like, it's really complicated. So I'm in the middle of doing that, and I'm just going to make a new cluster. And it's just pain. So what about Ganeti? So first off, what the hell is it? It's a cluster management tool for virtual machines. It's basically a tool that allows you to spin up virtual machines in a quick and easy manner on a set of compute nodes. You can think of it as a simple infrastructure service solution. It uses KVM or Xen primarily. It doesn't actually use libvirt. It has its own internal thing. It's primarily command line driven. It's very sysadmin focused. So if you're an ops guy, this is awesome. If you're not an ops guy, you might not like it as much. Just like anything else, so it supports live migration, and it also supports cluster rebalancing. The neat part about Ganeti is if you want to have a VM that you can kind of treat as a highly available VM, it utilizes technologies like DRBD. So it'll manage the underlying block device for that VM, and you can treat that VM, and you can move it from one host to another in case that node goes down. And the way Google uses it internally, which wrote Ganeti, it's basically they deal with commodity hardware, and they have an automated system that talks to the Ganeti API. And when a node goes down, they'll just move things over, start the VMs back up, or migrate it, and it just goes on from there. The best thing about Ganeti is it's a relatively simple architecture with minimal moving parts. There's no message queue daemons. There's no relational database. There is a database. It's a JSON file, but all the nodes are basically compute nodes, and one just acts as the master and controls the rest of the cluster. Adding more nodes is relatively simple, so it's really awesome. So what isn't it? It is not an entire cloud platform by itself. It only provides that compute part in the whole ecosystem. So if you look at it from an OpenStack point of view, it's basically just Nova compute and maybe some Neutron, and that's it. It doesn't have any object or image storage by default, and it's really not meant to be directly interfaced by general users. So unless you really trust your users, you're probably not going to give them CLI access to spin things up. So that's probably one of the biggest problems with Ganeti itself, is if that's what you need, Ganeti by itself, and I'll talk about another solution later, probably isn't the right thing. So kind of as an overview, you have your nodes, which are your compute nodes, your hypervisors. There's one node that acts as the master. You can move where the master is live. You can shut down the master. You can shut down Ganeti, and everything works as is. It's just the management interface. And then you have a virtual machine, and then if you have the VM set up to have the storage replicated on the back end, you can use the master node and tell it to migrate and do all of that. It's very, very nice. So a little background. It's a Google-funded project. It's been around since about 2007, but internally it's been there for a while. They use it internally at Google. From what I understand, they use it for development virtual compute clusters. So developers need access to VMs to spin up things, to test things out, or they can use it as like the VM they log into, the workstation VM that they log into to do the work that they want to do. They don't use it for any public cloud, like Google GCE does not use Ganeti. It's a very active and welcoming community, a mailing list and IRC. As they said, it started way before libvirt and OpenStack. So there's no libvirt. It's all internal, which can be good or bad. It's primarily written in Python and Haskell. You're probably wondering why. And I've actually talked to some of the core developers about this. It was originally all Python, and they were running into some scheduling problems with some things. And one of the core developers on a weekend, one of those weekend things, I want to try this in Haskell. I've been learning Haskell. He got this thing to work really well in Haskell, and they're like, hey, well, let's just see how it works inside. And they couldn't make it work as well in Python in the end, so they just kept it. They've actually been slowly replacing some parts of the internal code inside of it to Haskell where it makes sense. So I haven't actually upgraded our Ganeti cluster in a while because I've been so busy, but it's so stable that I haven't had to do that. But it really is, it's really, really cool how they have that. And they actually have a white paper out talking about this, so if you ever want to know more about it. No central relation database. They also kind of have a small little users Ganeti Cons on it, which has been pretty useful to kind of hear. When I went to one a couple years ago in Portland, the engineers at Google actually use it. They talked about their infrastructure, and it was crazy. They managed 9,000 or so instances or guests with a team of less than 10 people. So think about that. And think about if you had to do the same thing with an OpenStack cluster. And the only thing those people do is manage Ganeti itself and upgrade and manage that. They don't deal with the hardware, so they have separate people that deal with hardware stuff. But think about that. So Ganeti is really meant to be low-level entry to kind of get things going, easy to install, manage, and upgrade. The best part about Ganeti is upgrades. It works. It doesn't break. You can test it. You don't have to deal with rebuilding a new cluster. And the architecture by itself is pretty easy to understand. It's designed to scale to an enterprise scale somewhat, but you can definitely do more horizontal scaling. A lot of the limitation with Ganeti is the more nodes you add and the more instances you add, the backend management, since it doesn't use a relational database and memcache and all of that, the internal locking mechanism of Ganeti kind of slows down. But they've been working on making that better.
It's 1 to 200 nodes.
Yeah. As far as I know, yeah. And it's a really good open source community. They really actively encourage. There's a group of developers in Greece called GRNet that really embraced Ganeti and used it in their computing platform. And they've actually created a lot of third-party software that I'll talk about later. And they really encourage having that included. It's really awesome. So here's kind of another overview of the architecture. You have your nodes, and these are representative as disks. So the blue disk is like your system disk for the system, the hypervisor. And then the green is kind of your individually sliced block devices that you spin up on that node. And so you can see where you have different things. You can have node groups, which basically helps with VM allocation. So usually that means I want to keep it within a rack. I don't want things to traverse over a network segment or some kind. So you can kind of do that. So you can't, when you deploy a VM, it will stay in that node group. It won't have a secondary setup in a different node group. It's within that one node group. And it kind of compartmentalizes a lot of it. And they use the term instances instead of guests. So whenever I talk about instances, they're guests, just so you know. That's the one thing I kind of don't like about Ganeti is they don't quite use the same terminology that other people do. So now you remember that OpenStack slide I showed you of the architecture. Here,
Black and white.
yeah. Well, I have another one that's black and gray. This is the Ganeti design, at least from an API point of view. So you have a cluster, you have a master node, it has a set of processes running on it. There's this endpoint that's like the API endpoint, they call it the Looksy endpoint. They have a couple of daemons running and a job queue and then workers. And then on the nodes, there's a couple of daemons that run and that will talk and do the various things. They'll do disk management, network management, hypervisor type stuff. And it uses SSH to kind of interact with some of it. It uses SSH heavily to kind of interact and get things booted up and bootstrapped. So once you get a cluster set up and initialized, it generates an SSH key, and then when you want to add a node, it basically SSHs to that other node. As long as you have Ganeti installed in the same version, it'll copy all the configuration data and just add it into the cluster. And boom, you're done. Seconds, you got a new node added. Pretty simple. Maybe this might make a little more sense to some of you, but basically there's 4 daemons that run on the infrastructure. Usually there's only 2 minimum, depending on where things are. So every node has node D running. And node D is the daemon that does all the hypervisor stuff. It starts up KVM, it starts up QEMU, it sets up the block devices, it does all that magical stuff. The conf-D daemon is probably what you kind of expect. It's the configuration daemon. So it makes sure that the copy of the configuration file is basically a giant JSON file. It copies it to all master capable nodes. So you can set nodes as not master capable so that you can kind of, if you have a cluster large enough, but typically I've been setting them, everything can be master capable. That way I have that copy of that configuration copied to all 5 nodes. So if that one node goes down, I have another copy that's atomically copied all over. But it really only runs and functions on the master node. So the master node will talk to the other confds and copy things out. Actually, I think it uses SSH to copy it over. The RAPI, or the Remote API daemon, that's the actual API interface to Ganeti. It's a very simple API. It's not like OpenStack. But it allows you to do a lot of manual functioning. And what Google has done internally has created a lot of tools to interface with that and automate a lot of those operations. Now, they've actually included things in like remote power off of systems using IPMI commands and some of this. So it's pretty cool. And then the last one is masterd, and that's the daemon that basically ties everything together. And that's the one that runs on the master node. If you try to run any commands, the command line interface commands on a node that isn't the master, the command will basically say, I'm not the master, go to the master. When you go to the master, you can run all the commands you want to do.
So if the master goes down, does it automatically switch to another master capable node? Or?
No, but I think there's ways that you can automatically do it. The one thing they've added, support for doing like core sync or core sync, things like that, if you want to use it, but by default it doesn't. So by default, Ganeti needs human intervention to fix things. The nice thing is it usually doesn't take very long to fix things.
So if the master dies, do all the other nodes and the instances on it keep running until
Yeah.
you repair the master?
Yeah,
Okay.
yeah. And there is a mechanism to switch the master over to another VM. So say, for example, the master node, it's down for the count, it's definitely not coming back. There's a way to basically tell Ganeti, yes, I want to become the master, yes, I know what the heck I'm doing, because what you don't want to have is a split brain happen. Usually what happens is, if I'm just rebooting the server, doing a simple upgrade of the system, I'll just reboot it, and then it comes back and everything's fine and everything's hunky-dory. But everything else functions, but your management interface stops working, so you can't stop and start VMs, at least with Ganeti itself, until you get the master working.
So would you say, it sounds like you're not too concerned about like a multi-master setup or anything? Okay.
No. It basically it also manages a virtual IP that it moves between the cluster. So you have that virtual IP that moves between the VMs, and that's where the endpoints for the RPI is set up, so that everything can kind of talk to it.
So whoever's the master has that virtual IP.
Yep. So I usually just make a DNS endpoint for that virtual IP, and all the API stuff I have point to that. So I kind of talked about some of the terminology. The node is the compute hypervisor. The instance is the guest machine. A cluster is a set of nodes altogether. A node group is kind of a homogeneous set of nodes that's within a cluster. And then a job is just a single Ganeti operation, which can be start a VM, create a VM, list information, things like that. It goes through a whole queue and works through that. Storage in Ganeti is where things get a little weird and complicated. But it's gotten a lot better over the years. Historically, it doesn't by default use a disk image format like QCOW2, but it has the capability of doing that. It was originally designed with fault tolerance in mind, so they're using LVM with DRBD most of the time. So you literally have a volume group on that machine, you write to that block device, and that's where the actual disk lives. But they also have support for RBD using Ceph, so if you want to use Ceph in the back end. They also have support for BlusterFS. You can use file, both as local or as shared via NFS. So that's where you can use a QCOW2 image or whatever you want to use and do it that way. They also have an external storage provider. So if you've already invested money in an expensive SAN solution, all you need to have is use a standard set of APIs and write a storage provider that talks to it to allocate the VMs and the block devices. And then do what you want to do. And it's really designed to be as flexible as you want. But if you're looking at from the OpenStack world, it looks a little strange because it's not quite the same way. And honestly, when I first started using Ganeti, this was kind of how do I install the instance stuff was the biggest problem. That's my next slide. Deploying instances on Ganeti. It basically uses a bash script, and you use some of the environment variables that it tells it, and you basically do the installation however you want to do in that block device. So when I originally started doing this, the only option they had was they used deb bootstrap, and they would cache the tarball file, and they would just literally run makefs on the block device, and then copy that tar file on the system, and there you go. But I use Red Hat, CentOS. That didn't work. And I also support other operating systems. And this was really before, things like Packer existed and things like that for making images easily. So I created a image-based solution called Ganeti Instance Image that allowed us to kind of have the same templates. Originally, I supported file system dumps and then tarballs, but now I actually have support for QCOW2 images, and you can literally write directly to the device using QCOW image commands. And until I discovered grow root and Cloud Init, I didn't know quite how to grow the partition safely, and now that makes it a lot easier. There's another project called SNF Image, which is really similar to that, and both of these can kind of be used in the same manner that you use in OpenStack, but it's not as user-centric, at least using vanilla Ganeti. Like, you can't just have a user upload something and then there's your image. So that's another downfall. Like I said, the storage backend makes the VM things a little more complicated, but also makes it easier if you need to mount something really quick on the node to kind of fix things. If we have problems with, a project, we can just mount it and make it go. There's no Cloud Init support or metadata service daemon yet, but they've been talking about adding that and built into the Ganeti. I actually have added support for Cloud Init at a very basic level to Ganeti Instance Image, because I started using OpenStack and I was like, this actually is quite useful, and I can actually fix a lot of the problems I was having with Ganeti Instance Image. And I basically just use the no cloud option, and it sets up the IP address and everything, and grows the root partition, which is the biggest problem I had, and it works. It's really nice.
The image, going back to the image stuff, it basically mounts the block device local, right? And then you just write into that local.
Yeah, so like in the case of Instance Image, I have some logic built in there that if it's a QCOW2 image, I just, I don't even mount it. I use QEMU image and I do convert, and I literally take the file and it basically just writes it on the LVM block device. And then after that it mounts it, and then it can do some magic like setting the host name and stuff like that, or I can just use Cloud Init entirely when it boots up. Go from there.
What's Cloud Init?
Yeah. Cloud Init is a project that kind of stemmed out of OpenStack. It's a set of tools to, when you boot up a VM, you want to be able to set its host name, copy some SSH keys, grow the root file system, do all those kinds of things. It does other things. And what it originally is intended as, you have this metadata service listening on a specified IP address and URL scheme, and it basically gets that JSON file, it parses it, and then it boots up and sets everything in. It's a very handy tool, and you use it internally. I don't know if AWS uses it, but I'm assuming it does in some capacity. You definitely use it on OpenStack. And it just simplifies the whole VM partitioning, because you can basically tell it, go start doing my stuff, and it's kind of like Pixie for VMs in a way.
Well, in this case, I guess because Ganeti works different than other things where you have access to the file system before the VM ever boots, would Cloud Init not be quite as useful? Because in other cases where you don't have access to that file system, you don't really have a lot of other ways to inject data into that VM until it's booted.
Yeah, the nice thing about this is before I even knew about Cloud Init and how to use it, I basically used these hooks to kind of do things. So while the file system was mounted for the VM, I'd write bash scripts that kind of do the things I wanted to do, whether it was setting the config file for the static IP in there, or if I wanted to put a SSH key in, or I wanted to install something inside of it with a chroot, blah, blah, blah. But the problem I ran into is if I wanted to use the internal kernel and have it boot grub internally, grub2 made that nearly impossible to do with a chroot. And that was the problem I kept running into. But with Cloud Init, I just have that image is baked in, and it automatically grows that partition as long as you use a sane setup, and it works pretty quick. So I can basically use the same scripts I use to make my OpenStack images, but I just have them set for Ganeti, and I can have my images that are automatically built by Jenkins and whatever. So let me kind of walk through some of the concepts. So I kind of alluded to this before, but if you're using LVM and DRBD, the instances always have a primary and secondary node. So the primary node is where the VM actually is. The secondary node is where an identically sized LVM block device has been created and it's managed to have DRBD set up and it's synced. You don't have to do any DRBD sync or configuration other than making sure that it works. Ganeti actually uses raw DRBD commands to manage everything, and it only works on 8.3 right now, I think. They haven't added support for 9 yet. But the same thing works for the other templates. For example, if you just have an NFS share for all of your disk images, it's not going to do anything magical with the block device under because it's just a disk image. It's just going to assume in the NFS that it's always going to be available, and we can just spin it up on another node. So let's kind of walk through a little bit of a command line, walk through kind of what it looks like. This is better than doing a live demo, which I've done before. And this is a really slim version. I've done this presentation as a tutorial OSCON before, and it can get really, really deep into that. So to actually initialize the cluster, you have one node, and you run G&T cluster init, and then some command line variables, and that's it. You've initialized it. And then to add a node, you run G&T node add, and it SSHs to that node and adds it into the cluster and so forth. So assume I've already done that with this. All of the commands that you use in Ganeti. Oh, yeah.
Before doing what you just said, is this as easy as yum install Ganeti?
Yes.
Cool.
However, I don't think the repository isn't actually in EPEL yet. So there's this guy in Japan that has really done a really good job of maintaining a yum repository for Ganeti. The Debian project, people use Debian quite a bit internally, and they actually manage the upstream package. So the Debian and Ubuntu support is really good. The CentOS support is good enough. I just never had the time myself to be a contributor and getting it in the proper EPEL and all of that. But yeah, it's as simple as that. So you don't have to worry about compiling all the things. It just installs it into there. So in this case, I'm listing the nodes. I can see the information. You can add more fields if you want to see it here. You can see the list of operating systems. So here's the other weird thing about how Ganeti does things. So it has just OS templates, and then it has variants of those templates. So I created one called image, and then I created a variant called Cirrus or default or CentOS or whatever. The plus is to delineate the variant of it. So here I'm going to deploy a Cirrus image, and I'm basically going to say I'm going to tell it exactly where I want to put it. I want to use this image. I want to use the plain template, so it's just going to do LVM with no DRBD. It's going to be a 1 gig disk, and just for now, for fun, I'm just going to tell it not to start the instance, just to kind of make it go. So this is what it looks like. It makes it really quick, runs the OS create scripts. Less than a minute later, I have it there. You can see that it's there, but the instance is down. It's supposed to be down, and it's down. That's what admin down means. And there's a lot more command line options you can add here. Basically, especially with KVM, you have the full capable use of using anything that the environment that KVM can offer from the command line, but use at your own risk. So if you want to do fun things like PCI pass-through, have fun with that. And you can add multiple disks.
Is there a scheduler in the add? Like, will it go?
There is one, and I think, do I talk about it in the next one? I may not talk about it, but yeah. If you don't do it this way, they have something called an iAllocator. And you basically, the built-in one is called Hail. I can't remember what it actually stands for, but you, instead of the -n node name, you do -I and then Hail, and it'll internally figure it out. And it'll actually do n+1 redundancy. So if your cluster is too full and you don't have the space to add another instance and still have one node go down and move everything over to everything else, it won't do it unless you force it to do it. So it does try to keep things n+1 redundant. On the next slide, I'm going to show you some information. This actually goes on for quite a bit, but I'm condensing it to make it look like on the slide. But you can see all the information you want to know. You can see where it's going to be connected, the MAC address, where things are at. In this case, I'm using a bridged interface for the connection. You can actually do routed networking if you wanted to. You can see this is the literal block device that's connected to. If you want to shut down the instance, you just run a command to run it down, shut it down. It'll send the ACPI command and shut it down. Another cool thing, and I actually kind of requested this at one point, you can change the disk types, at least from LVM, plain LVM to DRBD. So in this case, I'm going to make it into a DRBD. I have to have the instance off to do it. I'm going to tell it I want to have it on node 2 as a secondary, and it internally renames all the LVM stuff, syncs it. You can see it syncing the device, and now it's changed to a DRBD setting. And now I have a replicated VM. So I can start that VM, I can do a migrate live, and it'll do all the magic for me. That's quite nice. Some other tools that I haven't listed here include things like HBOW. So after a long time of running a cluster, sometimes the cluster gets out of balance. And so you may have more nodes on one node, maybe more disk usage on other things, and so forth. Or you've taken one out, you want to add a new VM in and things like that. HBOW will literally go through and calculate a set of commands to rebalance everything live. So it'll literally do it'll switch a secondary, change the secondary, do a live migration, move things through. It's a pretty awesome thing to do. So you can actually move things around.
If you had 3 nodes, how does it know which node to put the replicated VM on?
That's where the Haskell part comes in. They do some statistical analysis. They kind of look at, okay, my next node I probably should put is here and then here, and based on my storage and memory and CPU overhead, which one should I put it on? It doesn't look at like live running instances, but it looks at what it knows in its database that's there. So if it knows I want to have this kind of a ratio of CPU, virtual CPU to raw CPU, or this for disk or RAM and so forth, it figures that out. So it kind of goes through a score and says, I think this is the best place of where it should go. Now, if you think you can write something better and it works for you, you can make your own iAllocator, as they call it, and come up with your own way of allocating instances. So some common use cases for Ganeti. Well, it's cheap, it's stable, it's very reliable. I can tell you, and I'll knock on wood, I have yet to have Ganeti cause an outage by itself. I have upgraded our production instance from version 2.0 through, I think the version we're running is 2.6. They're running 2.15 now, 2.15. I'm not that concerned about that upgrade. There's probably going to be some things that might break, but they do a really good job of how you do an upgrade and how you can test it and how you can go through all of that. They literally have tools that help you do it. You basically stop all of the daemons, you upgrade the packages. On the master node that was the master, you run a cfg update command, and it basically goes to the config file and updates it, any changes. It's kind of like doing a database schema update. You start master D, and I think conf D on there. You start all the daemons everywhere else. You tell the master to sync that new database across all the nodes. You restart all the nodes, and everything should be happy, hunky-dory. There you go. You're a new version of Ganeti. I've done that over and over and over and had very little problems with that.
Do you have to shut down the instances?
No.
You do that running?
Running. Everything's running. Because Ganeti is just a management layer. So you just shut down all the Ganeti daemons, those 4 daemons. And the nice thing is I just use things like DSH. They're distributed SSH, and I can point to a file on the file system that Ganeti maintains, and I can SSH and send the command to everything, or I can use, there's actually a GNT cluster command where you can just say SSH and run these commands, and I can just stop everything. And I can run all the other commands. But usually the step is do it that way. They've made some other new changes on it recently, and I haven't looked into it, but they have been very focused on making sure upgrades are seamless and stable and work. So this is really great for hosting, miscellaneous web websites and services and private. You have those pet VMs. It's really highly reliable, and it's really good to have as a medium-sized organization with a few sysadmins. So if you're very sysadmin lacking, this is a good tool for that if this fits within your user profile. So some of the pros: the architecture is fairly easy to deploy and understand and maintain. It requires minimal staff to really maintain it. It scales pretty well for at least the size of the OSL. We use it for all of our project hosting for now. It's really customizable. So if you want to change how things get deployed in the backend, you can do that. It has built-in redundancy, and it just freaking works. The cons, there's no GUI front end. There's third-party projects that do this, and I'll talk about that in a little bit. The API for Ganeti itself is not cloud-friendly. It's not designed to be cloud-friendly. It's basically, you can think of it as just the Nova Compute API is basically how you can kind of look at it. And the management of the system kind of gets slower as the cluster grows, but they've been making a lot of improvements in that lately. So any questions about Ganeti proper?
I'm guessing you're using this just for bare metal.
Yep.
Version. You have racks and how many racks runs?
Well, we don't have that many racks,
Yeah.
but our main production cluster has like 5 nodes, and we probably run about 30 VMs on each of them.
It seems to me that, in a way, this is not an alternative to OpenStack. It's an alternative to libvirt and Red Hat's libvirtuals. It's really automation of KVM, right?
Mm-hmm. Yeah.
Have you looked at where today Red Hat's and the community's libvirtuals are compared to Ganeti? Because I haven't looked at it lately.
I haven't looked at Overt. Would probably be the closest thing to that with libvirt,
Okay.
but I haven't looked at that lately.
Okay.
How do you manage the storage with Ganeti? I mean, if you had let's say 3 machines and you start running out of storage and you want to add more storage, how does that all get managed?
So you could either add more physical storage on that node, or you can add another node, and that has that storage. And then, if you wanted to, you can run the rebalance hval command, and it'll balance it out between the 3 nodes. Or you can just start deploying, and all the new things go on the new node. But usually, I would recommend rebalancing it after you add a node.
Is there console access? How do you get access?
You just SSH to the master node, and you run the commands, the GNT commands. That's how you manage it.
Like the KVM.
On the guests.
Yeah.
So you can have serial console access, which is great if you just need the prompt and everything. And you can access that through GNT instance, console, name of it. Or you can just have it use the VNC port. And then you can run a command to get the actual port that it runs and the node to connect to get to the VNC port.
And sorry if you're repeating, but the master in the node OS is Red Hat or Ubuntu or whatever you want.
Yeah. All right, well, I'm going to jump into the next part, which is how do we make Ganeti more OpenStack-like? So it's a really great platform, and it's really stable. And the guys in Greece I've known for a while have created this project called Synnefo. And you basically can think of it as Ganeti plus OpenStack APIs. It turns Ganeti as the underlying compute service and adds a couple more services on top of it and an actual API in front of it. You actually can manage the Ganeti clusters underneath it just like you can regularly. Synnefo just connects to it and adds an extra layer onto it. So it adds all the things that you would expect. Accounting, quota, block, storage. It's all written in Python, and it's really nice. I personally haven't had time to use it internally yet. It's been on my to-do list for a long time, but it's been used to quite a few things. So here is the architecture that they use. So here's actually... There's a little bit of color. I like how the sysadmin has a pipe that he's smoking, but the user doesn't. And so what I talked about before, this is an actual Ganeti cluster, and here's another Ganeti cluster, and it has all the usual things that Ganeti has, and then they add a layer on top of it. So here's what Synnefo is. They have these very Greek names that sometimes it's hard for me to talk about, but they have Cyclades, they have Akeros, and then Pythos. Basically, it's compute, networking, and storage. They have identity, and then some storage backend as well. So you have these APIs that are basically OpenStack APIs. They have a command line interface, kind of like the Nova command, or OpenStack command now I guess they have. And then there's a web GUI that's written in Django, kind of like Horizon. Primarily designed to run on Ubuntu or Debian, but they do have some Yum packages. So you can kind of look at these. So this is basically Keystone for Ganeti. This is the object storage. That is Swift, right? Or Glance. No, Swift is Pythos. Cyclades is basically Nova Compute, Nova Networking, Nova Glance, and Sender all in one. Kamakai is basically a command line interface, and then I think they just call it the web interface for the GUI and front end. So here's a little bit more detailed overview, and actually, let me see if I can do this without breaking my laptop. Make it a little bit bigger. Let's see here. Yeah. Anyways, they have a lot more daemons that they introduce. I'll have these slides up so you can actually read it later. But yeah, that looks a lot more like the OpenStack diagram I showed you before, and it basically is. But it probably, hopefully, runs a lot better than that. But it's even hard for me to see. But yeah, basically it adds all those various services to make Ganeti itself be the compute service that does all the hardcore stuff, and then it adds stuff on top of it. They've added a lot of support for Ceph, imaging, all sorts of fun stuff. So here's some screenshots. Oops. Whoops. Hold on. Need to get over here. Here we go. Oh, I just broke my side. Anyways, let me see if I just refresh this. It works. There we go. So here's a screenshot of like their virtual machine setup, so you can see like they have a Windows VM, they have a CentOS VM, and so forth. Here's a networking screenshot, so you can see kind of how things look. You can set up virtual networks, kind of like what Neutron does and OpenStack. They don't quite use the same mechanisms as Neutron, but somewhat similar. And it's really cool. It's something I've been wanting to look at, but I just haven't had time. But I would recommend you take a look at it if that's something you need. So let's talk a little bit about how the OSL uses Ganeti. We've been using it for all of our project hosting needs since 2009. We moved away from a handcrafted Zen cluster that used iSCSI and was slow as hell. And we did this all basically overnight. It took me a couple months of getting Ganeti to work the way I wanted it, and I've used it ever since. The only thing that ever broke on it was when I forgot to renew the SSL certificate for the daemons on the back end, because it had been 5 years since I had created the cluster. And the SSL certificate had broken. Well, that was easy to fix. So things like BusyBox is on Ganeti. If you go to the BusyBox website, if you go to, actually, this is fun, QEMU.org is hosted on KVM on Ganeti. Inkscape is on there. I mean, there's several other VMs. We use it for a lot of shared web services too. So instead of having physical machines like in our earlier days, we just set up a new VM. We run on Ganeti, and we kind of just treat it as a regular hardware machine. And yes, our controller for OpenStack that we're using internally is a Ganeti VM. It works. It does it good enough for what we need, because we don't have a lot of physical hardware. We don't want to just spin up another hardware for that. And really, if we want something that we want to stick around and has some high availability, maybe the application itself doesn't have the high availability, we put it on Ganeti. It's just as simple as that. OpenStack and OSL has kind of been a newer thing. We really haven't created a public or a project-based one yet. We've been using it internally quite a lot. And the reason I haven't opened it up, because of what I said in the very beginning, it's a pain in the ass to maintain and upgrade. And I want to make sure whatever we deploy is something I feel confident enough to keep around as long as I've kept Ganeti around. And so we're getting close to that. But we have an internal x86 one that we've primarily been using for integration testing. So we use Chef internally. We use Test Kitchen, which is a tool set. How many of you have heard of Test Kitchen? So a couple of you have. It's kind of like Vagrant on steroids for Chef. But it just talks to the OpenStack API. You have a set of suites. It spins up the VM. It'll install Chef if you haven't already. It runs the Chef stuff. Then I run server spec, and it checks to see everything is done, and then it tears it down. It's been really great for that. I've been using it for multi-node testing. I've actually been using it to test OpenStack Liberty, so it can spin up new nodes and do everything on that. It's a little annoying for that. But something else that's been interesting is on the Power Architecture, specifically PowerPC64 and PowerPC64 Little Indian. We've had a long-term relationship with IBM supporting the Power Architecture for open source projects. And in this latest round, they introduced Power 8. How many of you have ever used a Power machine before, like been an administrator of it? Okay, remember LPARs and how much of a pain it is with HMCs? Throw that out the window. it literally boots up like a regular x86 machine now with Power 8. It uses a little shim in there called Opal to act as the HMC, so to speak, and it uses IPMI, a standard, even though it sucks, but it's still a standard. And it boots up to Patet boot, which is basically Linux with a bootloader. And you can go to a prompt and do stuff and reboot it. Yeah, it's really crazy. But short story is they wanted us to build out an OpenStack cluster so that we can give projects access to that architecture to deploy and test on the architecture. They created a foundation to open up the architecture. They're trying to basically do the big thing that Intel, say we're going to open the whole thing up and get partners to go at it. So I had the fun of dealing with IBM engineers and working on bleeding edge patches to make libvirt and QEMU work on PowerPC, Little Indian. And I now have a working cluster, even though it is breaking because I'm still using Icehouse with OpenStack. So that's probably my biggest OpenStack cluster is that right there. And I'm working on getting it going with Liberty. So that's been a lot of fun. Let's talk about side-by-side. So OpenStack is really great for the quickly creating test VMs, integration testing. Also, if you need to have elastic computing needs, which is extremely complicated. And I really hate RabbitMQ and all the other things that related to that because things just stop working. How many of you have run into the problem with RabbitMQ where the node stopped working and you can't figure out why, and it isn't until you realize the storage, you're running really low on disk storage on the controller node, and MQ stops working when it gets to a certain percentage level that you don't have free on the disk. And I didn't notice that until I logged into the web GUI interface, and it's like, there's this red box down here. What is this? And I spent days trying to figure out why is nothing working. And yeah, fun stuff. I haven't had to do that with Ganeti. Ganeti, it's really good fault tolerance. It's really stable VM hosting. It's really easy to use and maintain and upgrade, but it just doesn't really fit that cloud needs if you need that, unless you add on something like Synnefo.
You mentioned elasticity as a benefit of OpenStack. Can you explain why it's better than Ganeti? Can you just
compute elasticity, right? Is that the one you're talking about?
What?
You said compute elasticity.
Yeah. Well, Ganeti will spin things up fairly quickly, but it kind of has this big master lock that they've been working on. So if you try to spin up 100 VMs all at once, it can take time for it to do it.
Okay.
If you do that on OpenStack, it'll usually do it pretty well in parallel. That's one limitation they have on that. And then on the deployment side, depending on what tool you use to deploy things, like internally, we actually have to manually edit some files to add the IP addresses because our internal DNS and DHCP service isn't quite working the way we want it, so we have to do everything static IP, so it takes us a while to deploy things. So internally, that's why it doesn't work well for us. With OpenStack, it has DHCP built in and all of that, and we created a network specifically for that. So Ganeti can do it, but it's not nearly as good as OpenStack. So kind of talk about future plans of what we're wanting to do at the lab. I'm hoping by the end of the year, if not sooner, open up an OpenStack cluster for projects to use, whether they want to do integration testing, build testing, so forth. I'm still planning on continuing having Ganeti alongside with OpenStack because it fits its niche, OpenStack fits its niche. They really coexist really well together, in my opinion. I'm really wanting to look into Synnefo as an interface between especially Ganeti and offering a similar interface for our users, potentially. That would be great. But like I said, I'm really planning on supporting both of the platforms long term. Ganeti's been around for quite a while, unless Google decides to can it, which we unfortunately know they like to kill projects sometimes. I have a feeling the community is large enough that it'll continue on, even if that happens. So the final summary, both fill a specific niche. OpenStack will eventually mature and be as stable as Ganeti, hopefully, and become more stable. It's getting there slowly. Give Ganeti a look. It might actually be what you need and don't need to deal with all the craziness that OpenStack is. Synnefo expands it. And make sure you experiment with these fully in a complete good environment with physical machines and test it out and fully understand how their maintenance works and work through that. So with that, any questions? We're hiring a sysadmin, so if you want to work with us, I have an opening that closes on May 3rd, so please apply.
I have a question. What do you do on the network? networking front? Do you just bridge or?
Yeah, we use a pretty simple network setup. So we have a couple of VLANs that we have just general network setup. We trunk those VLANs to the Ganeti node. The Ganeti node, the node IP is actually on a backend network, but we have public VLANs trunked to that, and then we trunk and create bridges for each of those VLANs. And then we deploy the instance. We just say go to this BR number of the VLAN.
So the node will add the .1q tag for each VM based on which VLAN it belongs
Yeah.
to.
Yeah, and in my case, I use the OS to manage the setting up the VLAN tagging and everything, and the instance just connects to the bridge and it gets a tap interface, and that's how it works. Right now I can't really do much on the networking side, more complicated. Ganeti has more support for doing more complicated things and actually doing pools and stuff. That came in a version after where we're at. And I'm hopefully going to look into that, and it does a lot better things. And Synnefo actually goes into that even more.
So how close do you think you can get to an OpenStack style cluster if you had Synnefo with Ganeti? And what would be the native that you can see now without having spent a lot of time with Synnefo? How close can you get to an OpenStack style with Synnefo and Ganeti if you wanted to go down that route?
From what I can tell, very close. I mean, obviously you can't get the extra services they've been adding on, things like Magnum and stuff like that. But if you just want basically Nova Compute, Neutron, and the block and store service, I think it's pretty close. I mean, I know they use thousands of VMs for the service in Greece, and there's a couple of companies that also are using it internally. There's actually some providers out there using Ganeti as their backend. So.
Any experience with Proxmox VE?
I have no idea what that is.
That's what I was going to
You really need to look into it.
What is that?
It's really good. It's a bare metal hypervisor, runs KVM, and it also supports OpenBZ and LXC containers.
Okay.
And it's been around for more than 10 years.
Oh, okay.
There's a company that does it as a mail host, hosting, and they needed something themselves, so they kind of created this project to meet their needs. And
Yeah.
Open source it.
Yeah. Okay. I got 3 more minutes. Any other questions?
Notice you haven't said Docker.
And we thank you for that.
They have added. I think they've added LXC support. I think they added LXC support. I don't think there might be some work on getting Docker to work, but it really just doesn't fit. Like, you would spin up a VM and then do Docker inside of it, which is what we've kind of done. Some
So when
places.
your users ask they want, can you do container-based CI runners or for testing or something? You just fire up your own.
I mean, yeah, we'll probably do that with OpenStack probably, because you can just fire those up and do whatever you want. And you know, the way our Ganeti infrastructure is set up right now, it's pretty hands-on on deploying things. OpenStack, we give you access; they can spin things up and do whatever they want. Cool. Well, thanks for coming out. I'll be around the rest of the day, and thanks for being here. Yeah, I'll post these on the website later today.
We're going to make it to the next room. We better hurry. Is it this room? I thought it was 114.
I thought we stayed here.